for about 2 years in production, and we've kind of grown tremendously the last year or so. We've been like sharded for about 10 to 12 months. Before that, we're kind of scaling up vertically. We collect billions of different data points each month. I'll kind of get into some of the analytics that we do. And I'm going to give you a summary of some of the analytics that we collect to kind of teach you a bit about how to do that in Mongo. So real quick, before I do that, I just want to tap Appboy and talk to you a bit about what Appboy is. So Appboy is a mobile relationship management platform for mobile apps. Basically what that means is we want to help our customers, people who have mobile apps, with the engagement of their users. And we do that through a three-step approach. The first part is understanding what your users do inside your app, tracking their behavior, kind of analyzing what's going on there. From there, we allow our customers to segment their users based on that behavior, based on their behavior in the app, their demographics, or their social network activity. And then from there, we provide a way for our customers to target users for automated messaging. And we have a multi-channel approach through push notifications, emails, and multiple types of in-app messaging. So real quick, I'll show you. Real quick, I'll talk about like use case that we have a lot of customers do. Customer onboarding. So I have 3 of our customers here: Urban Outfitters, Text Plus, which is a popular text messaging app, and Shape Magazine. And Appboy has an in-app messaging product that we call our newsfeed, which allows our customers to send down basically like Facebook feed style content into their app, but targeted at users based on their behavior. So one very popular campaign type that our customers run is customer onboarding. So you can see that each of these cards here represent a different message. And our customers do a drip onboarding campaign, meaning that what they want to do is send a message to you on day 1 of you using the app, and then on day 3 send you another message, and then on day 5 send another message, and then maybe on day 10 or day 14, based on your activity in the app, you might get either message A or B following after that. That's a really popular campaign that our customers run on Appboy, and the analytics that we collect help us be able to push that out. So more formally, I'll talk a bit about the agenda. The first thing I want to talk about is how we store time series data inside MongoDB and go a bit into flexible schemas. Flexible schemas are really a huge selling point and great advantage to Mongo, so I'll talk to you about how you can take advantage of that to store analytics like time series data and talk about breakdowns. And then lastly, I'll kind of switch topics and get into something a little more exciting, which is statistical analysis on top of Mongo when you have a lot of data. So I mentioned that Appboy collects a lot of data under the hood for our segmentation engine. So I'll talk to you about some of the analytics that we track and examples of it, and then we'll go into examples of how we store this. So one of the things that we track is time series data. Time series data is very easy to quantify. It's basically just some data point and time value. Like you can see a stock chart here at Tesla. Hopefully you bought it in like somewhere around there. But like examples of things that we collect: app opens over time, amount of revenue over time, any kind of event over time, like our customers with Text Plus, this text messaging app that tracks how many text messages are sent through their app each day. And then I mentioned that we have these messaging options like push and email. We want to track the efficacy of that. How many emails are being sent each day? How many are being opened? How many are bouncing? How many push are being sent, etc. So there's lots and lots of things that can be broken down to time series. Following up on time series, there's a lot of breakdown data that we want to show, basically represented as pie charts, things like device types, operating systems, the revenue by product, etc., any kind of screen resolution. And an interesting thing about breakdowns is that we actually really do care about this by time as well. And the reason is that you could look at, say, operating systems. If you want to track from the beginning of time all the breakdowns of operating systems in your app, you're probably going to have a lot of iOS 4, a lot of iOS 5, iOS 6. But really, it's probably a better representative sample to take maybe the last, say, 90 days or 120 days to really see what operating systems your customers are using. So break down the lifetime series and that you care about that over time, but you just display it in a bit of a different format. The last bit of analytics that we track, and then I'm going to go into today, is user segmentation and statistics about that. So I mentioned before that our customers use us to identify what their customers are doing in the app, and based on that behavior, segment them into groups. And so example groups could be users who have used my app for more than 5 days, or users who have spent more than $5 in my app, or users who have not used my app in over 2 weeks. We call those groups of users a segment. And there's a lot of questions that we want to know about those segments. How big is that segment? How many people have stopped using my app after 2 weeks? We want to know how many of those users we can reach, how many have email addresses on file with us, how many have push are push enabled on their device. How much money does that group spend on average? How much money does the paying user spend on average? Lots of statistics around that are interesting that I'll get into kind of how you can track that later down the line. So the first thing that I want to talk about is a use case of time series data going into pre-aggregated analytics, tracking app opens over time. Does anyone here track time series data? Any chance? Yes? Well, I have some t-shirts. I'm going to toss them out to anyone who raises their hand affirmatively. So a typical time series collection, you can see this in any kind of database technology, relational database, Mongo, is you're basically going to have a timestamp and then some identifier. So very naive implementation. You can see here, you log a new row every time a piece of data comes in. And then if you wanted to find the number of app opens you had after certain data, you can just do this query to look at how many opens did this app have after some data. This is extremely easy schema to put together. It's like tracking on day one. And it's pretty extensible. You can like add attribution, you can add a user ID, you can add a device ID, you can add all sorts of other things there that you can kind of track these data points. But if we want to show time series charts, it's not that good of a schema. And the reason is that you have one document per data point. And I mentioned Appboy's tracking billions of data points each month. It's really not going to be very feasible for us to aggregate that all up. You really only care about this data in aggregate. Also, if you guys have used MongoDB, you might know that MongoDB is very fast because it keeps documents in memory and it flushes the disk every so often, about once a second or every 100 milliseconds, does a different thing. And if you create a lot of records, you dirty a lot of pages, then have to be flushed to the disk. And so it can actually hurt your performance to make a lot of sporadic updates. If you're logging a point like this, but your mileage can vary based on your setup there. So let's kind of improve on this with pre-aggregation. So what pre-aggregation is going to do is we're going to roll up this data into a time that we care about. So at Appboy, we show time series charts by hour. So we'll start there and kind of roll this up on an hour, and I'll show you what that would look like. So you change the document here to group by a time period. You can see that I still have my app ID, but now I have a date, and then an hour, and then the number of opens per hour. And what you want to do is every time a new app open happens, you just find the app ID and the date, and then you just increment the count of the hour. So what happens is you end up having about 24 documents per day. And it's really easy to then take these documents and draw a histogram because each document is already pre-aggregated for you. So the pro is super simple. The con, though, is that if we store a document by hour, we don't really care about it by hour, then Mongo's data modeling principles would say that this should probably be something that's embedded. But additionally, kind of what goes with the con that I mentioned here is that in really the con of all pre-aggregated analytics is we start to lose attribution. So you saw on my previous slide, I said it's very easy to extend with user ID or device ID. We're losing that here, basically throwing the ability for us to do that out the window, because there's no good place for us to kind of put these user IDs and device IDs here. So that's kind of a con of any pre-aggregated strategy that we can talk about in a bit. So as I mentioned, we don't want to look at hours by themselves, so let's kind of embed them, so to speak. And with Mongo, this is super easy. We can create now a document by day and kind of jump up a level. So I've changed this a bit. Now I've got the app ID and the date the same. What I've got is I have 25 other fields now. I have 24 fields that represent each hour of the day. And then I have a total count. And then every time an app open comes in, what you want to do is increment the hour that it happened and the total count. And what this gives you is one document per day, which is a very low document count. If you wanted to look at the number of, look at the time series of the last 30 days, it's only pulling 30 documents from Mongo, which is very fast to do. Having the total number of opens up here by day also allows you to do aggregation framework calculations on top of it if you wanted to easily look at the number of opens per year or per month or whatever you want. Very, very simple to do that in one query. It'll also be pretty fast. Much like all the other pre-aggregated strategies that I talked about, or schemas I mentioned earlier, this should basically remain in memory. Because what will happen is that we expect this, as soon as this document gets created, it'll be in the working set in Mongo. And the working set means that it is already in Mongo's memory, and updates to it should be very fast because they're going to happen in memory. So,
you do targeted, or you enable targeted marketing, right? Based on hunters and users. So if you do this, you're losing user information. How do you do that?
Well, so as I mentioned, the pre-aggregation, you lose attribution, but But right now, I'm just talking about time series data. All I want to do is show charts. I haven't yet thought about how we're going to show target users based on their behavior. That's kind of the secret sauce behind what we do. But this sort of pattern is used a lot at Appboy for us to just show the time series data I mentioned. App opens over time, events over time, purchases over time, et cetera. Anytime we want to show a chart like that, we can pre-aggregate that and not have to go through the billions and billions of data points that we have. So there's a downside to that schema that I had, which is that it's pre-aggregated, sure, but there's no good way to look at other dimensions. If I want to look at the app opens by device, like what are the app opens on iPad, what are the app opens on the iPod, or on different platforms? That schema doesn't really do it. So how would you do that in Mongo? Any guesses? Remember, I have shirts. Arrays. Similar, so you can kind of look to embedding documents. The way that we do it is using a great property of Mongo, which is flexible schemas. Probably exactly what you're thinking. So check out this schema here. What we're going to do is we're going to dynamically add fields to the document as data comes in. So you look at this document here, we've got, it's very similar to what I last had. You've got the app ID and the date, and then you've got a totals count, and then you would have 24 other fields for hours, 0, 1, 2, 3, etc. But each of these now is an embedded document that we can break down by whatever dimension that we want. So you can see here that I've broken this down by devices. And so anytime an app open comes in, what we can do is look at all the dimensions that we care about and generate one update query to say update the totals. If it came in on an iPad Air, we can update this. If it came in from a mail user, we can update this. And now it's very, very easy for us to look at app opens by any kind of dimensional breakdown. So there's some pros and cons to this, just like any other approach. The pros is that it's very easy to add other dimensions. As I showed you, we had gender, and then we also had device type. If you wanted to add screen resolution, if you wanted to add whether or not there was a paying user or a non-paying user, very easy to do that dynamically. It's still going to be very fast, using one document per day. So if you grab those documents back and are showing it on the web form, imagine if you had a drop-down and you could choose the dimension. You don't have to re-query from the database because that's already back from, you already have all that data there. You don't need to make any further queries. And then the benefit, the thing that I hid this entire time, is you get the breakdowns for free. So remember that pie chart that I was showing that has an operating system version, or if you wanted to show like device type, you already have that. You can just look back in the schema, and you can see you have the devices, you have the number of opens on them. You can just kind of look at that to generate your breakdowns. You don't have to have another document. So it's a really useful property of this kind of aggregated document. Now the cons, this is kind of brought up in the question, is that you have no attribution at all in these documents. So pre-aggregation is not really a great strategy as your only analytic strategy. You would just use it as an optimization for, say, drawing charts or getting fast answers to questions like how many app opens did we have yesterday? How many app opens did we have this month? Very easy for you to do. Even as your data set grows to billions and billions of app opens per month, you still have one document per day that can answer all those questions, and you can keep getting those responses back in constant time no matter how large your data set goes. But a real big problem of pre-aggregated analytics too is that you have to know your questions ahead of time. So as I showed you on the last slide, we talked about the device breakdown and the gender breakdown. Well, what if we wanted to graph by age group? What would we have to do? Right, we have to add, kind of go back to the schema. Go back to the schema, we have to update our app code to start pre-aggregating by dimension. But the downside to that is that we wouldn't have any historical data. So if I wanted to push out a breakdown by revenue here in this app, and I coded that up today and I pushed it to production tonight, it's only going to start collecting data tonight. So all the time series charts that we already had don't get that dimension. So you kind of have to know those questions ahead of time for you to be able to take advantage of pre-aggregated data. But that can be okay based on what you're trying to achieve. So just in summary about pre-aggregated analytics before I close it out, I make extracting time series data very easy. You get the breakdowns for free. You can add dimensions. It's very, very easy to do. But as I said, I wouldn't rely on this for your whole analytics solution. You don't have any attribution. You can't ask ad hoc queries about things that you haven't thought about. So it's really not a great solution. as your only analytic backend. So does anyone have any quick questions before I move on to segmentation? Yeah?
The assumption is you store individual data points also.
Yes, you should do that.
So can you build ways of, now I want to collect something like this, or I've already got an individual record from update your data with through and redo your single date schema per day. Like, you've got a field in your individual records that you weren't aggregating before.
Sure.
Can you modify your code neatly in aggregation also?
So, if I understood you correctly, the question was, if you have a field that you're not already pre-aggregating, and you want to start pre-aggregating that, is it easy to start pre-aggregating it? Is that
Well, can you go back?
Can you go back in time?
Yes.
So you can go back in time if you keep track of all the individual data points. Ideally what you want in and this is kind of diverging from this talk, ideally what you want in a big data setup is something called Lambda architecture. And Lambda architecture, what that means is you have some system that has pre-computed very fast lookups on data that you care about. You've stored all your data in a way that you have that you have the ability to make an arbitrary function call on top of it. You can think of something like Hadoop. Hadoop, if you stored all your data in Hadoop, you could run an arbitrary Hadoop job that could pull your data back and then start re-aggregating that. So what you do is you have something that ideally is fast, but you can still answer any question you want. So if you want to start back populating it, you can do that. So I'm a huge proponent of you not throwing any data away. I don't think there's any analytics company ever that would say that you should throw data and drop it on the floor. But if you're interested in drawing time series charts on your website that can be very fast, this is a great technique that I think is very useful. Any other questions? Cool. All right, so next thing that I want to go into, if I can figure out which key is up and down, is how Appboy does user segmentation, but really how we use statistical analysis to count quickly. So I'll go and define what user segmentation is with a screenshot from our demo account that's available on GitHub. So this is a segment of users, and a segment of users, the way we define it, is a group of users in your app that meet some criteria. So I'm not sure if you can read this, but here we've got push enabled is true, age is older than 18, and country is the United States. And Appboy, by default, has about 20 dimensions on which you can add filters, and then you can log us event data or attribute data that you can then segment on. So we have sports apps that keep track of their users' favorite players, and they look at customers whose favorite player is LeBron James. We have other people who, like our text messaging app uses this, for example, to look at countries that people have called. Anyone who calls like the Philippines, and that was actually a campaign that they sent out last week, that they can just do using our simple UI. And then on top of this, we have some data. We have the total number of users, which in our sample app is only about 10,000. We can see that adding these three filters means that we only select 501 users, 420 of which are emailable, but all 501 of them are pushable. And the average revenue per person is about $2.11. So the talk about counting quickly is how do we do this? Because, sorry, what was it?
What was that last?
So this last metric is average revenue per paying user. So everyone who has paid, that's it. So the secret sauce of Appboy is that we show you this segment membership in real time. You can add, edit, remove filters, you can kind of tweak around with it. We'll update those statistics in real time. And we do it in what I call web speed. So I'll just kind of clarify this here. Real time you might think of as to the millisecond. But when you're on a website, you're tinkering with some analytics, and you change a value, and it tosses up a spinner, how long do you care that you have to wait? At what point do you get annoyed? Anyone? 5 seconds. All right, I don't know who said that, but I'm going to just throw this way. So yeah, okay, 10, 15 seconds, good. We think it's like 4. So we try to aim to make sure that it's like, not much more than 4 seconds, preferably way faster than that. But that's kind of what we're the target and kind of how I talk about we do this quickly. So the way we do this quickly is we estimate. For that sample app that I showed you that only had 10,000 users, you don't really need to estimate it. It's not very hard to scan that collection. But we have apps on our platform that have millions or tens of millions of monthly active users. And we want to do it for them just as fast as we do it for the people who have 10,000. So my goal again is that I can count quickly. But the problem, as you saw, is we have all these filters. We don't get to control what the user puts in. They have 20 dimensions that we provide, and then they can log arbitrary data to us and filter based on that. So the thing is, I have an arbitrary query that I want to get statistics about. And the problem is that MongoDB counts are really slow, especially on index ones. For those of you who haven't experienced this or aren't yet using MongoDB, MongoDB uses memory map files. So anytime it's going to touch a file, it's got to page that into memory. If you're going to scan like a document collection that has 10 million documents, you're going to put all those 10 million documents into memory. That's going to take a lot of time and push out some other things out of your working set. It's not really the best thing for you to do on a frequent basis. So let's go into this as an example. Let's say I have 10 million documents that represent people. So I've got someone who's got like a favorite color blue, he's 27, he likes pizza. And I have a lot of questions that I want to ask about this data set, these 10 million documents. Like I'm wondering how many people like blue? How many people live in New York City and love pizza? How many men have a shoe size greater than 10? So the big question is, how are we going to estimate the counts? And the solution is either be that we're going to do the exact same thing that the news networks do. We're going to estimate it using statistics. Anytime the news network says that they think that Bill de Blasio is going to win with 65% confidence or whatever they say, they didn't ask every New Yorker, right? They asked like a couple of New Yorkers, and then they try to figure it out. When they want to figure out which president's going to win the election, they don't ask all Americans. They just ask a few. They run some formulas. They take some samples, and then they're able to give you an answer, plus or minus some percentage. We want to do the exact same thing. All right, so let's kind of delve into what we would do. So the first thing that we do if we had this data set is let's just add a random number to every single document. And I'm going to put it in some known range and say it's between 0 and 9,999. So that's 10,000 random numbers I'm going to put on every document every time it gets inserted. One document's going to have a random number on it. And I'm going to put an index on it, so that way I can kind of search that collection pretty quickly. So the first step that I want to do is get my random sample, just like the news networks do, and they call up random people and they ask them questions. I want to do something similar. So I've got 10 million documents, and I have 10,000 random buckets. So what I would expect, each bucket should hold about 1,000 users. So if I look at all the users who have a number 1, 2, 3, should be about 1,000. All the users who have 9,000 should be about 1,000. 5, 6, 7 should be about 1,000. Any number you pick between 0 and 9,999, you'd expect there to be about 1,000 users in there. So now what we'll do is we'll get our random sample. What I'm going to do is I'm going to take a random 100,000 users, and that's what we're going to look at. So we can take a random range that holds all those. So remember, each bucket holds 1,000 users. So if I want 100,000 users, I should look at about 100 buckets. I can also choose this randomly, just to keep with the fun. So any of these kind of buckets work. I can go from 0 to 101. I can go from 503 to 694. I can even wrap around, going from 9955 all the way to 56. So that's what we're going to do. And Mongo has an operator called max scan that you can use to tell Mongo only scan this number of objects. So just to be safe, in case we don't have about 1,000 users per bucket, we're going to max scan that, put it at 100,000. So once we have our sample size, we're going to learn a little bit about it. So here's what we're going to do. We're going to look at this random size, this random sample, for all the males who like blue, who have a shoe size greater than 10. We're going to max scan it to 100,000. And then Mongo has a command called explain that will show you what the query did. How many documents it looked at, what index it used, how many things matched it, how many times it yielded. There's a lot of data that you can get out of there. But we only care about two things, two outputs. One is called n-scanned objects, which is going to tell you how many documents it scanned. Another is n, which is going to tell you how many documents match the criteria. So if you look at this, you see that we scanned 100,000 random documents, and about 11,000 of them matched. So from here, it's just math. You just take the population, the sample size, the matches, that's about 11.3%. Now, if you go to Google and you type in sample size calculator, what you can do is you can find a calculator that allows you to enter these three things and spits out that it's plus or minus 0.2%, given a 95% confidence. So we do that exact same thing, and then we actually put it at the bottom of that segment page. It says we give them the confidence interval, and we tell them how confident we are. So there are then some things that you want to do to optimize. There's some other cheats. If you're sharded, you can actually max scan to 100,000 divided by the number of shards you have. So otherwise, I'm assuming that you're going to query all shards, scanning so many users like this. That'll be even faster than that. You can cache the random range. This is a great property of Mongo that it has, is that once documents are in memory, it's very fast to do queries on them. So say you technically load up a random 100,000 users into Mongo's memory, any subsequent questions you want to ask about it, you could expect to be way faster than the first question, which might have had to page things into memory. So all those users can sit there on our dashboard, they can tinker with male, female, likes pizza, likes sushi, or whatever. They can change all those values, and it should be even faster than our first result. There are other optimizations you can do, like adding more RAM to making sure that your working set, or as much as you can, stays in memory, and paging in 100,000 users doesn't knock out other important things in your working set. And then there's some other cheats you can do to cache results and not hit the database again. If I'm going between male and female and male and female, just to look at what the difference was, you don't want to hit the database. There's some other cool things you can do. You can also cache partial results, so that some queries don't even have to hit the database at all. But that's a little more advanced. And then lastly, you can kind of improve on this. You can get more than one count. The thing that I showed you just was how to get the number of users that match that query. But remember that we want to know other things. How many of them can we reach by email? How much money do they spend? How many can we do via push? So you can use the aggregation framework on top of this to get more answers to your questions. Though once you start getting into here, there's going to be a lot of Mongo bugs that you run into. So buyer beware. This stuff's like the depths of this Mongo scaling stuff can get a little complicated. Because explain, also I probably would not put that into production because it's not a standard operator, it's more of a debugging tool. And also then you can run into queries that hit things like multi-key indexes that could throw wrenches in your operation here. So anyone who gets to this stage, if you have any questions, I'm more than happy to go and decide on how we work around some of these Mongo bugs to get this going. So real quick, just to summarize, this kind of getting to the end of the talk. We first talked about pre-aggregated analytics. The way that you do this is you create a document that represents event occurrences in time period, and the document itself is kind of rolled up to a time period that you care about. And this takes full advantage of Mongo's flexible schemas. You can add all sorts of dimensions that you want to it. And a reminder that this is not a catch-all. Please store all your data. Do not throw data away ever. And then from there, we talk about kind of quickly. You can estimate the results of arbitrary queries using a sample size. And depending on your app, this could be great. When we have customers that have tens of millions of monthly active users, if I'm off by plus or minus 0.2%, I don't really care. I'm just trying to show it to them on the web dashboard. So it's a great application for us to do it. But of course, your application could vary from that. So that's all I've got. I have 3 more t-shirts in random sizes. If you guys have any other questions on anything I talked about here, feel free to let them rip. Yeah.
Which other aggregation function you use? Because you showed us really submission right here. Let's say if you want to keep track of averages, how long do you do that?
Yeah, I mean, that's kind of where you start running. Like, so the question was, the aggregation framework's good for keeping track of some of these things like counts, but if you want to keep track of averages or medians, you can kind of run into some pitfalls there. So that's the territory that we've tinkered with a little bit, and we haven't used the aggregation framework for it. We've taken our sample size, we've used raw Mongo driver to, in a background thread on another worker, or another server even, run some of that data, and then push it back to our application layer. So we kind of split up some of the statistics. So I think you saw on our dashboard here, oops, nope, you did not see it, because I broke it. Sorry for this. You saw here that you have all these statistics. We've experimented with adding better statistics that are more computational intensive, and then having like a spinner like this. So maybe all of these 6 statistics load first, and then we have other statistics underneath it that load in individually that we take up with background processing that get secondary databases that we can afford to be a little more computationally intensive. Because the thing is, remember, I'm optimizing for web speed. I want our customers to tinker with filters to see how this changes. If this data comes back in 2 seconds and then this data comes back 3 seconds later, so yeah.
So, like, what do you do in terms of collecting data on the actual devices? Are you, kind of logging it and then just periodically sending it up? I mean, I'm just concerned about how chatty it would be, for instance.
You mean in terms of our like SDK that sits on the mobile device?
Yeah, mobile device, it's not constantly sending up data, I assume, right? So
Yeah, so I didn't even talk about this, but the gentleman here assumed what would be true is that Appboy has a mobile app SDK that goes inside your app. If you have an iOS app or an Android app, you put our SDK in, you log event data. And we try to not be super chatty. Spinning up the network radio is very expensive on other devices. You don't want to kill the battery. So we take advantage of a couple different things. We opportunistically, like on the Android, we have way more control of what we do. We can opportunistically send out packets up when we know that the radio is already being used. We queue data to not send it up very, immediately after you send it. So there's a lot of optimizations that we've tried to do to make sure that we're not impacting your app's battery life. If anyone has any questions about Appboy as a product, I have plenty of business cards and can get you a t-shirt mailed to you. If you are interested in putting us in your mobile app. Yes?
Have you used MongoDB across data centers within the same cluster? And if yes, how does it really perform?
So the question was if I've used MongoDB across data centers. That's something we haven't ventured into, and I'm a little afraid of when we get there. So don't have a good answer for you, but no, we haven't ventured into it yet. Yes?
Do you guys do anything where you provide historical data for custom filters?
I'm sorry, historical data?
For custom filters, so can I draw graphs based on just custom filters that I create?
So
Because this is just a spot trend.
yes. So this goes back to the thing about pre-aggregated analytics, knowing the questions ahead of time. Let's say you create this segment of users who are push-enabled, who are older than 18 to live in the United States, and you want to look at their app opens over time. Problem is, you can't do it using pre-aggregation for historical data. If we took advantage of that, if we had that feature on our dashboard, which we don't yet, and we wanted to use pre-aggregated analytics, that would be a downside, because remember, with pre-aggregated analytics, you have to know the question ahead of time. So I can't start tracking whether or not users who are opening the app are in this segment until I've created a segment, and then going forward I can track it. That we've thought about, and we haven't pushed it out yet. We think it's probably acceptable for our customers to accept that. For us to say, you create this segment, and then moving forward you'll see it. You create a segment, and a week later you're not going to care, because you'll have all the answers you want. So for our application, that sort of thing can work. That does not work for all applications, though. Google Analytics, though, did release that, where they allow you to create a segment on your web property and then apply historically, and that's why Google is fantastic. Sorry. Yes?
You mentioned watch out for the Google bugs. Doing my first POC using aggregation. Now, where's the things I should look out for?
You can't hint using the Mongo aggregation framework. This is a real big pain in the ass. So, for example, I showed that in where we had the index on random. We put an index on random, and one optimization that I think I left off the slide is if you do it exactly as I described it, you're going to want to hint that random index. And what hinting is, for those of you who don't know, is you're going to tell Mongo to use a specific index that you've chosen. If you don't do that, Mongo is going to try to run a lot of different indexes all at the same time and pick the winner. And what happens is, you're going to end up, you could end up, if it picks a bad index, scanning a lot of documents. So even though you think you're scanning 100,000, you're not. You're scanning way more distinct documents than that. You're just doing it across all these different indexes. So that's a big pain that we've had to work around. And then going from there, looking at any kind of the way that Mongo treats multi-key indexes, there's a number of bugs that are open in Jira in terms of Mongo not being able to use its multi-key index effectively. There are like 3 or 4 different classes of bugs that I'm thinking of that I can get into in more detail. But like you kind of, there be dragons here. Like when we actually like try to do this. This is not like, this is why our secret sauce is so good. It's hard to do. But I definitely look out for not being able to hint. The 16 megabyte size limit in Mongo is extremely annoying. They're fixing that though in 2.6. So you guys are not stopping being a year late. But so was that? Oh no, the results from each of the pipeline operators or pipeline operators has to be 16 megabytes, because especially if you're in a sharded environment, you get things that then kind of aggregate up to the MongoDBs to perform aggregation. That's my understanding of it. And if you grow past 16 megabytes there, it's just going to fail. So there's parts of things that we tried to use the aggregation framework for, and then we added another pipeline operator, and then Mongo said, sorry, you used more than 16 megabytes worth of space, we're just going to kill you. And we're like, what?
Yeah.
Totally unreasonable. And they realized that, and they're fixing it. But it's not out yet. So,
It will be soon.
it will see. Yeah.
So, how do you like deal with the bugs and figure out what's a bug and what's not a bug?
So,
Like,
might just be
test it
classic,
or something to make sure it's a safe.
so with Mongo, a great way to tell if it's a bug or not a bug is explain. Explain is there to help you know what is Mongo doing. And then there's things that we do. We have a great support team. We don't host MongoDB ourselves. I would love to, but it's pretty complicated, so I outsourced that to a company called Object Rocket, which then has a premium support contract with MongoDB Corp. So on a number of occasions, we've had to escalate our issues up to Object Rocket, who then have to escalate it up to MongoDB. That they're here in New York City is great. We've gone in for office hours on so there's tomorrow. We've gone in before, we've sat with the engineers and we talked through what's bug and what's not bug, or if we're doing something badly or not. So taking advantage of the resources they give you, I think it's a good way to figure out it.
So yeah, that begs the question, John. What made you decide to go with Mongo for everything? Did you see the stuff, like the ratio stuff? This is very cool. It's very smart. Would you do that with another database if you chose it, or
So-
is it something that just happens to happen because you're using Mongo?
Yeah, I mean, you could. I kind of sympathize a little bit with Mongo when I think about it, because they don't, like, these indexing problems, I feel like they don't know the relational structure ahead of time, especially a lot of people who use Mongo kind of like they would use your relational database. You have a users collection, you have an apps collection, you have a devices collection, and they're all related, right? Users have devices, devices have users, devices use apps, etc. Mongo's not always that good for that kind of data. There were a few things that drew us to Mongo. One was that I was really excited about using new technology, because I just quit a hedge fund and I really want to use cool stuff. So, story of what, probably lost other people are. So I wanted to try it out. We were working on a problem that was unrelated to this, that was similar to a problem that Foursquare had blogged about, and we were like, oh, Foursquare uses Mongo, maybe we'll try that out. And then we've kind of expanded on this. Being able to do the fast queries in memory has been a huge boon. When we were early on, we were like, should we switch off Mongo and go on something else? And we did speed tests, and for some of the queries that we were thinking we would make, which we then later, some of them we made, some of them we didn't. It ended up being pretty good, and in some cases a lot faster. Like the time series data, really cool. You can do some of that like pre-aggregation using stored procedures and transactions in a relational database, but that flexible schema stuff that you get, it's just dead simple for us to do something like that. And then the segmentation stuff, I mean, literally, I went to React training, I went to MongoDB stuff, I tried some Postgres, like went to Google BigQuery, I tried all sorts of stuff to say this is the problem that I'm trying to solve. I have all these users that have all these properties, and I want to filter them by an arbitrary number of arbitrary properties. And I didn't have a really good solution, and this was the best thing I could get that was pretty fast.
Yes. Hey, this is too big for me. Do you want to give this out again?
Sure. I'm sorry, I only brought large. Is this a large?
That's medium.
Medium? I only had through my backpack for like 8. Anyone have a last? Wait, you had a question. Here. This is a medium. Yeah, that's right. Any other questions? I wrap it up. Nice. Cool. Thank you guys.